let's take a look at some examples of adding and subtracting rational expressions. I wrote out a list of steps in simplifying rational expressions by addition or subtraction, but we're going to go over them as we practice an example. Now, the example we're looking at is one where we have common binomial factors in the denominator. So let's get started. We have x over 2x minus 4. Remember, step number 1 would be factor completely all denominators and only the denominators. And that's what we're going to do. So we have x in the numerator. Nothing happens to the numerator, but denominator in factored form, we can take out 2, which is the greatest common factor, and then x minus 2 minus. In the next rational expression, here we have 3. And then 3 is a common factor in the denominator, so, and then x minus 2. And then plus 1 over 1. So interestingly enough, you can see that here we ended up with a common factor of numerator and denominator. It's a numerical factor. When we have a numerical factor, we can easily simplify. It doesn't actually hide any restrictions because they're numbers. So we're going to take an extra step to write this same expression in a more simplified form. So we have 2 times x minus 2 minus 3 and 3 will simplify into 1. So 1 divided by x minus 2. And then plus 1, which we agreed to write as 1 over 1 as a fraction. So in the next step, what we want to do is determine the lowest common denominator. So our focus will be on the denominators, and the way I like to do this is by listing all the possible factors for all the denominators. So I start with the first. The first denominator has 2 factors, 2 and x minus 2. The second denominator has only 1 factor, the binomial x minus 2. And the last denominator has only 1 factor, 1. 1 doesn't count as a real factor because it doesn't change the product of the expression. And we're going to say that now we're ready to state the lowest common denominator, which is found by bringing down every factor. So we have a factor of 2. And then we have a factor of x minus 2. Since it is common, we only list it once. And that would be the lowest common denominator in our case. So in the next step, we're reminded to state the restrictions. It is better to state the restrictions of the lowest common denominator when we are adding and subtracting expressions because the lowest common denominator contains all the possible factors, with one exception when sometimes we simplify common factors that contain a variable, which is not the case here. So we're going to look at such examples in the other exercises in this same lesson. So our job now would be to state the restrictions. Now, as you can see here, we have 2 factors in the lowest common denominator. Now, one of the factors is numerical, so which means that we already know the value of it. We know that number 2 cannot equal 0 ever because it's 2. And the only restriction that we can list in here is the one that comes from a factor that contains a variable, which is x minus 2. So we'll say x minus 2 different than 0. X has to be different than 2. So that's the only restriction we have to list in our case. And next, let's take a look at our steps. We have to make all rational expressions with the same denominator. So we are on step 4. And what that means is that we're going to revisit every term in our rational expression here, and we'll try to make all the denominators same as the lowest common. So as you can see, the first term, it's a rational term, x over x minus 2 times x minus 2, has the denominator same as the lowest common. It doesn't need any changes, so we'll leave it as is. And then we have minus 1 over x minus 2. Now, x minus 2 here is going to need a factor of 2, so we'll multiply it by a 2. Because we have to multiply by a binomial here, the binomial has the same brackets, and also we need to multiply the numerator by the same number, so by number 2, so that we ensure that in overall we have multiplied the entire rational expression by 2 over 2, which is 1. Lastly, we have number 1. And the denominator is 1, which means that this is going to need a factor of 2 and x minus 2. And obviously, we're going to do the same thing, multiply both numerator and denominator by the same factors. Now that we know that our denominators are the same, so we have 2 times x minus 2 in all the denominators, we can bring all these terms together in a single rational expression of the denominator 2 times x minus 2. And then we can simplify the numerators. So we'll bring all the numerators together in the same numerator. So x from the first, negative 2 times 1, that's negative 2. And lastly, we have 2 times x minus 2, which we can actually start expanding. 2 times x, that's 2x. And 2 times negative 2 is negative 4. Next, we will want to simplify the numerator. So as you can see here, we have 2x plus 1x. That would be equal to 3x. And negative 2 plus negative 4 would be equal to negative 6 over 2 times x minus 2. So far, we have brought the expression in the most simplified form, meaning that everything is in one single rational expression. Let's take a look at our steps else we have to do. So we combined all the rational expressions into single rational expressions, all terms in the numerator, and always denominator in factor form. So we did this. So this is check. And step 6, we have to check and see if the numerator is factorable. Well, let's take a look. So as you can see here, we have 3x minus 6. Numerator has a common factor of 3 and then x minus 2. And denominator is 2 over x minus 2. Well, surprise, surprise, we end up with a common factor in both numerator and denominator. They obviously simplify because they divide to 1. So the value of that rational expression we were working on would be simply 3 over 2. Now, I want you to think about this. If you didn't write the restrictions at the moment when we were supposed to, which is right after you state the lowest common denominator, then the restrictions will be hiding in the final answer because they simplified. But that doesn't mean that the restrictions didn't ever exist. And that's why it becomes very important to remind ourselves that restrictions must be listed before we completely simplify the expression, because sometimes they get simplified in the process as well, and we may miss them. All right, so in the next example, you have another rational expression to simplify. I encourage you to try this on your own. I'm going to go over it as well. You may pause the video and try to do it on your own and then check the answer later. So now that we know the steps, we don't need to check each and every one of them. So we're going to go ahead and inspect every term. It is very important to inspect what you have. You have 1, 2, 3 terms. The first and the last are in rational form. The middle one is a monomial and it's numerical. When this happens, then what we want to do is make it into fractions just to make the denominator visible, so we won't forget this constant term. It gets easily forgotten, and it's a mistake that is very easy to make, to miss this small little term. So that's why I want to make it a little bit more visible by giving it a denominator of 1. So let's get started with finding the lowest common denominator, and for this we need to factor all the denominators. So let's see. So we have 5 and then x plus 5, and then minus 3 divided by 1 plus x plus 3 divided by 3x plus 5. I think I'm ready to state or to find my lowest common denominator. So I will start with the factors of the first denominator, which are 5 and x plus 5. The next one has only denominator 1. The next one has 3 and x plus 5. So since x plus 5 is already one of the factors that we need to take into account for the lowest common denominator, so we're going to list them below each other. And then the other factor, which is 3, will deserve a special spot. And now we're ready to state the lowest common denominator. And we're going to bring the 5 down. That's a factor. And then x plus 5 is common, so That means we have to list it only once. And lastly, we have the factor of 3. And we're going to write this in a more simplified form as 5 and 3 combined to make 15, and then x plus 5. So this would be the lowest common denominator. We haven't simplified any of the factors in the denominator, so as you can see in here, which means that we can state the restrictions right off the lowest common denominator. So similarly to what we did before, we're going to say that 15 is already a number, don't need to state restrictions on it, but x plus 5 has the potential of becoming 0. So we're going to write x plus 5 different than 0, which means x has to be different than negative 5 because x being negative 5 can make this denominator equal to 0 and the expression undefined. So that would be our restriction. So I like to either circle or box them up. Oops, let's make this nice and pretty. And I would state this is the restriction. And now we're going to start making all the denominators the same. And that is because we want to combine these rational expressions, and we cannot combine them unless the denominators are the same. So I'm going to write the first rational term. So the denominator is 5x plus 5, which means that to make it 15, I need to multiply it by 3. So to multiply denominator by 3 means I have to do the same to the numerator. And since you have a binomial in the numerator, be sure that the binomial stays in brackets, and every term in the binomial this way will multiply by 3. Then we have minus. Here we have a denominator of 1, which means that we need to make this denominator into a 15, x plus 5, and we'll multiply by 15 x plus 5, the numerator as well. And next we have the last term, which is plus. We have x plus 3 in the numerator, and denominator is 3x plus 5. So to make it into a 15x plus 5, we got to multiply by 5 both numerator and denominator, and keep this nice numerator here in brackets because it's in binomial form. So as you can see now, all the denominators are 15x plus 5, which means that we can bring this entire expression under the same denominator in a single rational expression with denominator 15x plus 5. And now we'll work with our numerators. So we have the first numerator here, 3 times 4x, 3 times negative 1. So that's 12x minus 3. Now, next we have minus 15. And we'll take a little bit of time in here. So no one gets lost in the process. So I'll multiply first the 3 and 15. Obviously, you can skip this step and you can just expand the whole thing. And then lastly, we have 5 times x, 5 times 3. So 5x plus 15. So let's bring them all together. And now we have 12x minus 3 minus 15x. Now 15 times 5. My bad here, so I just missed something. Good thing I realized right now. So 3 and 15 would be equal to 45. And we have minus 45x, and then minus 225, 45 times 5, yep. And then plus 5x plus 15 over 15x plus 5. Never expand the denominator because we want to wait and see, check and see if we have any common factors with a numerator. And to simplify, we need to have the expressions in factored form. So we're going to simplify all the x terms, so bring them all together. 12 minus 45 plus 5, that would be 17 minus 45, or negative 28x. And then we're going to have negative 3, negative 225 plus 15. That will add to negative 213. And that would be over 15, and then x plus 5. Now, as you can see, there is nothing we can take out in this case. We can take out a -1, but if you leave the answer in this form, it's totally fine. So you can take the negative out and to write this as 28x plus 213 over 15x plus 5. But I don't see any factor in the numerator that can simplify with the denominators, and this will be the final